So you can tell this is kind of a preview of what we'll do here in just a bit outside, but you've taken 2 angle measurements, and then the 15 is the distance between those two, so that length. And this is just like the one we did with the tree and the one on your test that was the parade balloon thing. I can't remember exactly the wording. Okay. So we need this angle up here so that we have an angle in its opposite side, the 15. How do we get that angle? There's an easy way. It's called the triangle exterior angle sum. So if we look at that triangle, the 45 is an exterior angle to that triangle, meaning it's on the outside. And it is the sum of the opposite interior angles. We call those the remote interior angles in geometry. In other words, this 45 is the same as 36 plus theta, the two opposite in the triangle. So that saves you a little bit of work. So theta is what? Theta is 9. Okay, now we have our law of sines. We can do sine of 9 over 15. And then we want to find either of the 2 dashed lines. So which do you want to do? Short one, sure. Let's call that x. Again, we're trying to find h, the height of the pole. Okay, so then we go an angle, which is 36, sine of that angle, and its opposite side, x. Okay. And this is all fairly familiar at this point. Okay. X. Good. So divide both sides by sine of 9. And what'd you guys, well, let's see if everybody got the same, but what'd you get on that? 56.3, and that's feet. Okay. All right, and then how do we get h from there? So that is now 56.3. And at this point, you have a couple options. Did you say something? Okay. Okay, so for h, at this point, we could go do a right triangle since we know that this light pole is pretty much perpendicular. So what would we do there? What are you going to do there once you get out there? Trig ratio, sure. So this is sine of 45 equals h over 56.3. So we just multiply those two. And h is, what'd you get on that? Here, I'll just do it. So sine of 45 times 56.3. So 48, if we round, 48 feet. So 48-foot pole. Did you have a question? Oh, since it's 45, 45, 90? Yeah. So just multiply by root 2? No, divide by root 2. Yeah. Cool, good job for seeing that. Okay. Oh, here's why. This dumb calculator. Basically, anytime I turn off the iPad, or exit the calculator, it resets. So I'm still in radians. So tell me what you got.
We got 39.9, but we got
to 40. Okay, thank you.
And then we added the 5.
Good. Yep, and then your last step, add the eye height. So overall height, maybe capital H, is 45 feet. So you'll need to, when we go out, you'll need to measure your eye height like we did before, which is pretty fast. Okay, so that's the process you're going to do. All we're going to add to this is that you have to do the 2 measurements of the angle and the 2 lengths. So measure the 2 angles, 15 feet between, 20 feet, however much you want. I probably wouldn't do like 2 feet. That's not going to have enough change in the angle. So 15 is probably roughly good, but it doesn't have to be right on that. Maybe 10 is okay. Okay, and then measure your height to your eye to add at the end. I want you to keep in mind, this is important, just understanding how the math works. If you're off in your angles or this 15-foot measure, that could severely impact your calculation for the height, right? Because this is getting thrown into trig and multiplication and division, etc., repeatedly even. So those three need to be really accurate as you can. This one, if you mismeasure your eye height, that's only an addition thing. Like if you're off by a few inches, you're just changing your overall total by a couple inches, like big deal, right? So you could ballpark your eye height, okay? Don't stress about that one. Again, because you're just adding that total to the end, which is not a big deal. Here's a couple of examples real quick of things I've done for students in the past. And height of a radio tower. This is how you can use this various versions of this math. But before I show you these, this is kind of weird since we're like no phones, but if you're willing, and we don't need everybody to do this, but we need the Clinometer app downloaded. It's free, and actually there's multiple ones, but it's free and it's pretty small, so I don't think it's a data issue. That's what it's called. You can just search that if you're willing. We need at least one per group. So we might have to rearrange groups depending who's going to get that. You don't have one. Okay. Do you have a phone? Because, I don't know. You guys partnered last time. Okay. Who are you with? Huh? You always have a phone? Can you put that on there? Is that okay? Okay, let's go ahead and do it. I need to put it on mine as well. I usually have this on mine, and I think I took it off recently. It doesn't have to be a specific one, so whichever one is most convenient, and obviously definitely do a free one. The one that I've gotten in the past it looks kind of like that. The image does. And it seems to have worked. I wonder if my iPad could, I bet my iPad could do it. Oh well. Okay, once you have it, can you guys kind of see mine?
Yeah.
You want to hit like this one that I downloaded, the one that I showed you. On the top right side of the circle, there's an arrow. And basically what it does is make it so that when you're looking horizontal, the clinometer says 0. That's how you want it. Okay? It defaults to this being 90 or something else. So turn it to where it's 0 and it's horizontal. You're going to be with Isla? You don't have a phone? Yeah. You can't? Guess you're going to have to make one. Do you have a straw? Good idea. That's some improvisation there. Good job. Okay. So once you have yours downloaded, maybe you can borrow. I want you to just kind of mess around. So, like, let's say I'm looking up at the top of the flagpole. If you've ever shot a gun, you're like sighting across the top of your phone like that, okay? If you haven't shot a gun, here's what you don't want to do. Like if I want to aim my phone at the top of the flagpole, I don't want to do this where I'm just like looking at the point and lining it up. I need to line up the entire top. So it's more like this, okay? It's like looking across the top of a ruler towards the top of the flagpole. So think of shooting a gun, okay? And then, so I'm gonna look and sight on the top of that flagpole. Okay, it's lined up. And then most of the time you can tap these. Let's see if this one does that. Tap, tap, tap. You'll have to have your partner read it. Because for this one, it has a lock button, but it's really small. Like, what's the point of that? Yeah, have your partner read it. I'll try this again. Okay. Everybody got it working?
Yeah.
Okay. Where's yours?
It's confusing, but I think it works. I don't know.
Well, I mean, the biggest thing is make sure to have it where it's 0 and it's sideways, instead of 0 and it's like this.
Mine has like a surface. It's like a top, and then like there's like 2 degrees.
Okay.
And one's 0 and one's like 20.
I can look at it when we get out there. Okay. So here's like how you'll see this when you get out there. I'm going to show you. Will you turn the light off actually, please? A couple of different examples of this. So go ahead and put those back in your pockets till we get outside. Here's one. It's the height of a radio tower. This is in the area that I live. One day I have noticed this guy has this enormous radio tower in his backyard. I mean, I assume it's a guy. And I was like, good grief, I wonder how tall it is, okay? So there's the radio tower from a distance. Can you see it over here? This is just a personal, like somebody's. This is driving down the road, so it's not a great picture. Okay, this is from my drone. You can see it's enormous, this thing, right? Like here's his house and it's going clear up there. So it's kind of interesting, like how high is this radio tower? So I took 2 measurements. Here's what yours are going to look like. Let me show you that in a second. Okay, so I took a screenshot of the clinometer. It was 6.09 degrees sighted to the top of that tower right there. Right, and this was a ways back. You can tell I was pretty far away. And then I got a little closer. So my angle got a little bit more because I'm closer. It's only about 4 degrees. But now I'm looking up again at the top of the tower just a little bit closer. So those are the 2 measurements that we took. And that's how it will look on yours roughly when you do the measurement. Okay? The 2 points that I took those from, now I did it fairly far away since the object was distant. Your guys are going to just use a tape measure. But I measured 85 yards between the 2 points where I took the angles. Okay, so do you see like our warm-up, it was angle, angle, and then distance along the ground. Okay? So I think these were the calculations. Yeah. Okay, so that's the picture. Same thing that we just did, and same exact math, just with different numbers. Okay. Here's another one. If you've ever been to Arches. What was that? Oh, by the way, the thing was 88 feet tall. That's pretty tall for a backyard. It's like almost 10 stories for a backyard antenna. Does anybody know that guy? Okay. If you've ever been to Arches, this is called the pipe organ. And this thing is huge. Like my picture doesn't do it justice at all. So I took the first one was 49 degrees. The second one was 54. I got a little bit closer. 63 feet in that case, so not super far apart. And I was trying to sight to where I put the star to the top of this thing. Okay. And did the math and got 447. So like I said, this thing is an enormous rock structure. It's cool. If you ever go to Arches, the road goes right by it, in fact. Okay, so 447 feet. And then this one, I was actually able to look up the actual height, and it was a little bit more. It was like closer to 500. But I will tell you that the day I did this, my family and my parents were coming back from hiking, and so I just jumped out of the truck, and I didn't actually measure with the tape measure. I just paced it off, so that 63 was probably a little off. But it only took me literally like probably 2 minutes to do the measurement. Okay, and it was pretty close. Isn't that cool? Okay, there's a picture of it from a distance. You can see that it's pretty big. So when I did that, the road curves over and there's a parking lot right here. So I was like looking kind of pretty straight up at it and did the two measurements close by it. Probably would have been more accurate if I had been further away. So this is good stuff that we're doing, right? It's real math and it's kind of fun. So I'm going to have you'll need a tape measure and your phone this time, that's all. And of course, I'll hand you a paper to document. But also I'm going to hand you the paper from before, from when we did the shadow and the mirror. And I want you to compare your results to the answers you got there, and also the method, and see which one, if you remember those, see which one you like better. Sound good? Will you do the light again? So bundle up.